Hello everyone, welcome back to Board Express PCM. In this video, we are going to be master in our last topic, Gauss law from chapter first, electric charges and field. In this video, we will know about first area vector, second electric flux, third Gauss law and its application. So let's start from our first topic, area vector. Area vector. It is the vector associated with every area element of a closed surface and taken in the direction of the outward normal. यह एक वेक्टर है जो कि सभी क्लोज सरफेस के एरिया एलिमेंट से जुड़ा हुआ है और यह हमेशा क्लोज सरफेस के नॉर्मली आउटवर्ड निकलता है. Our next topic is electric flux. Electric flux linked with any surface is proportional to the number of electric field lines that pass through that surface. इलेक्ट्रिक फ्लक्स किसी भी सरफेस के नंबर ऑफ फील्ड लाइंस के प्रोपोर्शनल होता है जो उस सरफेस से पास हो रही है. इट इज ए स्केलर क्वांटिटी. एसआई यूनिट ऑफ इलेक्ट्रिक फ्लक्स इज न्यूटन मीटर स्क्वायर कूलम इनवर्स. Our next topic is Gauss law. It states that the total flux through a closed surface is equal to 1 upon epsilon naught times the net charge enclosed by a closed surface. गॉस लॉ हमें यह बताता है कि टोटल फ्लक्स किसी भी सरफेस का 1 अपॉन एप्सिलॉन नॉट और टोटल चार्ज जो क्लोज सरफेस में इनक्लोज है उनका प्रोडक्ट होता है. इलेक्ट्रिक फ्लक्स इज इक्वल टू क्लोज इंटीग्रल ऑफ ई डॉट डी एस इज इक्वल टू क्यू अपॉन एप्सिलॉन नॉट. हियर वी यूज क्लोज इंटीग्रल नॉट इंटीग्रल बिकॉज इन दिस वी टेक क्लोज सरफेस वेयर q is equal to net charge inside the Gaussian surface. If medium charged, electric flux is equal to q upon k epsilon naught. Our next topic is application of Gauss law. There are some application of Gauss law. First, electric field due to infinitely long uniformly charged wire. First, we draw its image. For charged wire, we need to make a cylindrical Gaussian surface. From Gauss's law, E is equal to lambda upon 2 pi epsilon naught R. Derivation of electric field due to an infinitely long charged wire. Here lambda is uniform charge density, L is equal to length, R is radius. You can also see its diagram. Electric flux is equal to integration of E dot ds cos 0 degree plus integration of E ds cos 90 degree plus integration of E ds cos 90 degree. Electric flux is equal to EA. Here A equal 2 pi RL. Electric flux is equal to E into 2 pi RL. Electric flux is equal to Q upon epsilon naught is equal to lambda L upon epsilon naught. Here Q is equal lambda L. Lambda L upon epsilon naught is equal to E into 2 pi RL. E is equal to lambda upon 2 pi epsilon naught R. Hence proved. You can also see its graph. Electric field due to a thin infinitely plane sheet. First we draw its image. For a thin infinitely plane sheet we need to draw a cylindrical Gaussian surface. From Gauss law, E is equal to sigma upon 2 epsilon naught. Derivation of electric field due to thin infinitely plane sheet. Here sigma is surface charge density. Electric flux is equal to integration of E ds cos 0 degree plus integration of E ds cos 90 degree plus integration of E ds cos 0 degree. Electric flux is equal to 2EA. Electric flux is equal to Q upon epsilon naught equal to sigma A upon epsilon naught. 2EA is equal to sigma A upon epsilon naught is equal to E is equal to sigma upon 2 epsilon naught. Hence proof. Electric field due to thin charge spherical shell. For a point outside the shell small r greater than capital R. E is equal to 1 upon 4 pi epsilon naught Q upon small r square. Derivation for point lying article the shell. Here r is spherical shell radius and sigma is uniform charge density. After making Gaussian surface, electric flux is equal to integration of E dot ds cos 0 degree. Electric flux is equal to E dot A, where A equal 4 pi r square. Electric flux is equal to E into 4 pi r square. Electric flux is equal to Q upon epsilon naught. On putting the equation, Q upon epsilon naught is equal to E into 4 pi r square. Electric field is equal to 1 upon 4 pi epsilon naught into Q upon r square, hence proved. For a point lying on the surface, small r equal capital R, on putting small r equal capital R, E is equal to 1 upon 4 pi epsilon naught Q upon capital R square. Since sigma is equal to Q upon 4 pi R square, E is equal to sigma upon epsilon naught. For a point lying inside the shell, small r is smaller than capital R. E is equal to 0, where Q equals 0. Derivation of inside the shell, electric flux is equal to E into 4 pi r square. Electric flux is equal to Q upon epsilon naught equal to 0. Electric flux is equal to 0, hence proof. You can also see its graph. Our first chapter, electric charge and field, is now over.